Hello, my name is Casey Shibler and I'm doing a reassessment video on circuits 1. I've chosen the problem that says two circuits are assembled using 1.5 volt batteries, thick copper wire connecting them, and thin filament bulbs. Bulbs A, B, and C are identical thin filament bulbs, so they're all the same. The compasses are placed under the wire at identical locations. Boom, 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 boom. On the sketches of the circuits, draw the directions of the compass needles will point and indicate the approximate magnitude of the compass deflections in degrees. Note that the deflection is given at one location. If you do not have enough information to give a number, then indicate whether it will be greater than, less than, or equal to 5 degrees. It says to assume that they're adequately far away from the steel jack batteries. So, this is what I've done. For part A, for figure 1, I have that the compass deflection is 5 degrees north. That's the one that they gave me, and it's going to be deflecting in that direction. So that means this one down here will be deflecting in that direction. I know tan theta is equal to the magnetic field of the wire over the earth, so we don't really need that for this. The compass deflection is dependent on current, so therefore the second compass in figure 1 will also deflect 5 degrees, but it'll just kind of be like negative because it's going in the other direction. The current stays the same in both direction and magnitude throughout. Since this splits into parallel, I'm assuming that this is going to be greater than 5, and then this will be 5. But they didn't really give me anything for this figure except for the voltage of the batteries. So I put in regard to the compasses in the second figure, 2 are placed by the batteries and 1 is placed in the part of the circuit where the bulbs are parallel. So there's these two. These two magnitudes are going to be greater than this. So these two compass deflections are probably going to be double what this is going to be since it has the split. However, it can be said that the deflection of the compasses nearest the batteries will be twice that of the compass in parallel, not series. That's wrong. Don't look at that. I meant to say parallel. This is due to the current in parallel having to be split, so it will end up giving the original amount in the end. So like say if we had I1 equals I2 plus 3, I3 equals I4. That's what that means. So part C says on the same sketches of circuits show very approximately the distribution of surface charge. We know that the positive surface charge will be over here and the negative will be over here because of the positive and negative ends of the battery. As it flows through, we have a thick wire flowing into a thin wire. So I like to look at current or charges flowing from a thick wire to thin wire, like trying to squeeze water from a thick pipe to a thin pipe. So we're going to have a pretty large buildup of negative charges over here and positive charges over here. The same can kind of be said for figure 2, so I don't really have to go into that, I guess. Then it says on part D to calculate the electric field inside all of the bulbs. Well, all of the bulbs are identical thin filament bulbs. So basically, you're going to have we know our EMF is equal to the electric field times the length of the filament. So we have electric field is equal to EMF over L, which is 3 volts over 0.004 meters, which was given over here. It says the tungsten filament in each of the bulbs is 4 millimeters long with a radius of 6 times 10 to the negative centimeters. Okay, so we get 750 volts per meter in light A, over here, and then 750 volts per meter in light B, and 750 volts per meter in light C, because they're all the same. Thank you, and this is